Okay, 8.3. Today we're going to talk about what is a matrix. So, a matrix, for example, A, B, C, D, is a 2 by 2. It has 2 rows and 2 columns. Whereas the matrix A, B, C, D, E, F is a 2 by 3. It still has the 2 rows, but now it has 3 columns. So, two matrices are equal if the dimensions are equal and all corresponding pieces are equal. For example, number 7. We have a 2 by 2, x, 2y, z, 9, set equal to 4, 12, 3, 9. What this means, since our dimensions are both 2 by 2s, 2 by 2, and 2 by 2, check, then our corresponding pieces need to be equal. So if we take x, which we list as A11 because it is in the first row and the first column, needs to be equal to the same one in my second one, A11. So that means that our x value has to be equal to the same position, which is the 4, the 2y has to equal 12, z has to equal 3, and 9 has to equal 9. Since that's already 9, we have y is 6, and we've solved for all 3 of our variables. So, with our matrices, we can add or subtract as long as they have equal dimensions, like our 2 by 2 or 3 by 3, etc. In our book, we have an example where we have 1, 3, 5, 3 added to 3, negative 2, negative 1, 6. So we add our corresponding positions, so 1 is added to 3, giving us 4. Then we have 1, 4, 9. If we change this addition problem to subtract, we do the same thing, but we subtract the corresponding 1 minus 3, negative 2, subtracting 5, subtract, get 6, and subtract, we get negative 3. So that's adding and subtracting. Now let's switch. And let's do multiplying. So if we want to multiply matrices, we need something slightly different. So let's say we had 1, 3, 5, 3, 3, negative 2, negative 1, 6. In order to multiply these equations, they have a 2 by 2 and a 2 by 2. The middle number needs to match. So they're both 2's. Now that means our resulting answer is going to also be a 2 by 2. It's my remainders. How we multiply? Well, we know it's a 2 by 2. We're going to take our first row times our first column for our first row, first column spot, 1, 1. 1 gets multiplied by 3, gives us 3. 3 gets multiplied by negative 1, which is negative 3. Add together, 0. Now we're going to take our first row times our second column for our first row, second column spot. 1 times negative 2 is negative 2, and 3 times 6 is 18, giving us 16. We have no more columns because we have no more columns to multiply by. So we move on to our second row. So second row, first column spot, because it's using the second row in the first column. 5 times the 3 is 15, plus the 3 times negative 1, which is really minus 3. 15 minus 3 gives us 12. And last but not least, second row, second column, multiplying for our second column spot. 5 times -2, -10 plus 18 makes 8. So 29 says the matrix 1, 2, 3, 4 multiplied by the matrix 1 column 1, 2, 3, 4. So again, we check our dimensions. This one is a 1 by 4. This one has 4 rows, so it's a 4 row, 1 column. Again, looking at our middle numbers need to match. They do. And our remaining numbers, 1 by 1, tell us that our final answer, because we only have 1 row, 1 column, is going to be first row, first column spot. 1 plus 1 times 1 plus 2 2s, 3 3s, and 4 4s is all one number, which adds to make 30. So you notice again the remaining answer. If we were to switch these, we would still have our inner numbers because this is a 4 by 1 and a 1 by 4. Middle numbers still match. But now I know my answer is going to be a 4 by 4. Because each row and each column get multiplied. I get 1 times 1. Then I get 1 times 2, which makes 2. Oops. And then 1 times the 3 is 3. 1 times the 4 is the 4. First row, fourth column spot. Now we move on to the second row. 2 and 4, 6 and 8. Third row, 3, 6, 9, and 12. Fourth row, 4, 8, 12, and 16. So our final answer is a 4 by 4, whereas previously we had a 1 by 1. So multiplication is not commutative for matrices. They're commutative otherwise, but again, not for matrices. Now let's try problem 40, which wants us to take A times B plus C. A is the matrix 4, 0, -3, 5, 0, 1. And then B is 5, 1, -2, -2, plus C, which is 1, -1, -1, 1. Always do our parentheses first. These are both 2 by 2, so we can add them. And we're going to get the 5 and 1 is 6, 1 and -1, 0, -2 and -1 is -3, and -1. Now we're going to take that and multiply by our A. Again, we're going to take each row in my 3 by 2, make sure it matches. Take our first row times our first column. So we get 4 6s, 24, plus 0 -3s, which is 0. Moving on to the first row, second column spot. We have 4 times 0 is 0. 0 -1s is also 0. Second row, first column, gives us -18 plus -15. The second row, second column, 0 plus the -5. Now our third row, we're going to get 0 plus -3 and 0 plus -1. So we get our final matrix, 24, 0, -33, -5, -3, -1.